All right, welcome back here. We're going to be talking about day number 12 notes. These are application problems with linear functions. And today we're going to expand upon or build off what we talked about in day number 11 notes, which we're dealing with slope-intercept. So let's read the first scenario here, dealing with the basketball problem. Reserved tickets for the basketball game cost $3 each, and general admission tickets cost $2 each. Let X equal the number of reserved tickets Hank sells. Let Y equal the number of general admission tickets that Hank sells. So one is talking about reserved tickets. Those are X values. And then we also have here, it says let Y equal the number of general admission tickets sold. So what we need to recognize here is that we have two rates going on here. It says that the general admission tickets are going to cost $2 each. And it tells us there's another rate here that a reserve ticket is going to cost $3 each. And what I'm going to tell you to do is to note there are two rates. And oftentimes when we get a problem like this, instead of writing this in slope-intercept form where we'd have one slope, here we're going to be looking at writing this in what we talk about as standard form of a linear function, because we are given two rates. And what I want you to do is to think about that. If Hank was to sell one reserve ticket, that would cost $3. If he sells two reserve tickets, that's going to be 2 times 3, which is $6. If he sold 3 of them, it would be 3 times 3. If he sold 4 of them, it would be 4 times 3. So the idea here is that Hank is going to be charging or selling $3 for however many reserve tickets he sells. If we looked at the second rate, it is going to cost $2 based upon how many general admission tickets he sells. And at the end of the day, this problem here in part A tells us that Hank must sell exactly $30 worth of tickets. So that's how we know here that this is going to have to equal $30 as we set up this equation in standard form. But again, we talked today about standard form because we were given two rates. Quick little recap here. It says, can we find our intercepts for the equation? Remember, the intercepts are going to be those points that are going to lie on the, in this case, x-axis or y-axis. So to find the x-intercept, we're going to let y equal 0. If I solve this, we get 3x is going to be equal to 30 because 2 times 0 would be 0. If we divide by 3, we get x is going to be 10, which is 10 comma 0. I'm going to change colors just to separate the two. But now we're going to do similar for the y-intercept. With the y-intercept, we were going to find the y value when x is 0. So if I do that, I get 3 times 0 plus 2 times y equals 30. 2 times y will equal 30 when y is 15. This ordered pair is 0 comma 15. We look at part C there, and it says, since only a whole number of tickets can be sold, x and y must be integers. From your graph, find all the order pairs that satisfy them both being what we talk about here as integers. So before we can move into that part, I do need to make sure that we put some labels on our axes. We need to scale it. So down here, I'm going to put this x-axis. If we go back and look at how the variable was defined, this is the number of reserve tickets sold. Over here is the number of general admission tickets sold. We are going to want to make sure that we do plot our x-intercept and y-intercept respectively. If I count out the number of tick marks on this grid, there's 20 going left and right. there's 20 going up. So what I do know is that I am allowed to count by ones, because I only need to get out to the right 10 and up to 15, and there's 20 tick marks. Again, I'm not going to list every one of them. I'm going to list the evens. And if counted correctly, we'll get out to 20. Likewise, when we move vertically, we're going to count 1, 2, and then 3, 4. But as I do that, I'm listing the evens. We're going to want to plot this. I'm going to plot 10, 0 right here. And I'm going to plot 0, 15 up here. I'm going to draw my line in that's going to represent this. And as I take a look at this here, I'm going to move into this part C, because this part C is getting into something that we need to realize, that if I looked at like this first point at 1, that is not at 1 comma 14, that's not at 1 comma 13, so we know that that's not really a point that's going to make sense in this scenario, right? We have to be able to sell a whole number of tickets. So if we take a look, the next point that kind of looks like it lies on a grid line would be 2 comma 12. How do we know if 2 comma 12 works? Well, the way you could determine if it works is you plug it in C. So if you did this, you'd get, put a little check here, I'm going to get 3 times 2 plus 2 times 12, which is 6 plus 24, and that's equal to selling exactly $30 like Hank was supposed to. If I would like to find another one that's going to work, we notice that there might be a combination right here on a grid line, which is 4 comma 9. And then we get 6 comma 6, and we get 8 comma 3. If I repeat that pattern one more time, I get down there at 10 comma 0. So it says, what are the combinations that work? We said the combinations were 0, 15. We said 2 comma 12, 4 comma 9, 6 comma 6, 8 comma 3, and 10 comma 0. Notice as we look at that on the graph that that is following what we learned in this chapter earlier and last chapter, that this is a slope or rate of change. We're going down 3, so decreasing the general tickets by 3, and moving to the right 2 to increase the reserve tickets by 2. So that's down 3 and right 2, and down 3 and right 2. And those would be all the possible coordinates that work. As I slide into page 2 of this, again, we're on another problem here. And this one says, you are taking a trip to the public library. You travel in small and large vans. A small van holds 8 people. A large van holds 12 people. Your class could fill 15 vans. Sorry, that's 15 small vans and 2 large vans. Well, we would have to define our variables here first. And then that's going to help us move into setting up a scenario where we're going to problem solve here. And we'd be trying to figure out by what means would we be able to get our class or our students to the library. So as I take a look here, I'm going to get here, let x equal the number of, let's say, small vans used. And we're going to let y equal the number of large vans used. Part B asks us to consider how many people are there in your class. And sometimes we look and say, I'm not sure how many people there are in our class, but this sentence here that I'm about ready to highlight is the one that's going to help talk about exactly how many people are in our class, because we're going to assume that we are filling these vans to capacity. We're not going to have extra seats left over. So if we know that our class could fit into 15 small vans, we know that 15 small vans would be 15 being multiplied by, remember we said that a small van is going to hold 8 people. So if we had 15 small vans, that's 15 times 8 people per van, which if I multiply that out, that is going to give me 120 people are fitting in those small vans. In the large vans are going to hold, what, 12 people it says? And it said that we were utilizing for our class 1 a possibility was 2 of those. So 2 times 12 is 24 students. So what's the total number of students? Add those two numbers together. The total number of students is going to be equal to 144. Probably not ideal that they don't give us a lot of room here, but we're going to make do, right? So let's take a look here. Write the equation that models the combinations of small and large vans that your class would fill. Again, we're going to head back to the top, and we're going to recognize here that as we're writing this equation is that we have a small van holds 8 people, a large van holds 12 people. So that is saying 8 people fit per small van, 12 people fit per large van. So again, what we notice here is that we're going to be writing this in standard form because we had 2 given rates at the start of the problem. So if we do the small van first, 8 people are going to fit in each small van. Remember, small vans we said was X plus Y was the large vans, and that is 12 people. According to this right here, 12 people are going to fit in the large van. And that needs to equal the total number of students in our class, which we already computed back in part B to be 144 students. Next thing we're going to do is we're going to be asked to graph this. If we'd like to graph this, it's helpful to label our axes. So this is the number of small vans used. I'm going to have to turn my iPad a little. This is going to be the number of large vans used. So we have our labels. The next thing is we'd like to have a scale, but right now it's a little bit difficult to get the scale because we don't have any points. So as we saw in the last problem, the points we'd like to try to utilize are the x-intercept, where we let y equal 0. And if I do that, I get 8x is equal to 144 divided by 8, which tells me that x is going to be 18. And we can plot that point at 18, 0. I'm going to slide this over. I am also going to look to find the y-intercept. And that y-intercept is going to be found by letting x equal 0. And if I do that, I get 8 times 0 plus 12y equals 144. Let me see if I can do a better job with this. which is going to give me 12y is equal to 144 divided by 12, and y is equal to 12. And again, we remember from the previous problems that this is going to give us 20 tick marks. It actually gives us a hint here that we can count by twos. So I'm going to go 2, 4, 6, and then we're at 8, 10, 12. That's going to give me all the way out to 40. We're going to count likewise vertically by the same twos that they gave us. And as I graph this, we're going to be graphing 18, 0, which is, I'm going to change my color here to be my blue line. 18, 0 is here. 0, 12 is there. And we draw our line in. Again, we can't take a half of a van. So what question E is asking us to do is asking us to list several other combinations that work. Well, if I like to list several other combinations that work, what I need to recognize here is that the other combinations that will exist are going to come from a specific pattern. And again, what that pattern is, may not be obvious initially, but if we look at our grid lines, I notice that it looks like there's a point that plots right here and looks to be 6, 8. That's right on some integer or some whole number coordinates. I see another one right here, which would be 12, 4. So they ask you to list some combinations that work. Some other combinations that work would be 6 and 8. There'd also be 12 and 4. And again, remember this is the number of small, the number of large vans utilized. We also have the points that we just found a moment ago, which are 18, 0, and 0, 12. There are actually a couple others as well. That again, if you found the slope, that might help you be able to locate those. I will let you kind of tackle that on your own, or your teacher can address that too if they have questions. All right, last problem here we're going to look at is it's called the rafting problem. And with this rafting problem, it says a student council treasurer is preparing a budget for a class rafting trip. Each raft, large raft, costs $100 to rent. Each small raft costs $40 to rent. And they are giving you a budget of $1,600. Well, what we want to do here is read that scenario again and figure out what are those unknown things that we're trying to deal with. So as we are trying to plan this trip, we need to be trying to figure out how many large rafts are rented, because we already know what they cost. We just need to figure out what or how many that we're going to get. And then this is y is going to be the number of small rafts. I'll just slide that over then. So again, we're going to be asked to write an equation that is going to model the possible combinations of small rafts and large rafts that you are able to rent. And as we read the top here, we need to recognize that we have a raft that costs $100 for a large one. So that's $100 per large raft. And a small raft is going to cost $40 per small raft. What we recognize here is, once again, they are giving us two rates. When we have two rates, we're going to be able to set this up in standard form. So if I want to set this up in standard form, we're going to deal with the large raft first, and we know that it costs $100 per each large raft. So we're going to multiply that by the number of large rafts we'd like to get. We know that a small raft is going to cost $40, and we're going to multiply that by the number of small rafts rented. And we are given a total budget of $1,600. Letter C here says, can we graph this? Well, in order to graph it, again, we're going to need to scale our axes. We're going to need to label our axes, but we would like to find some points. Remember those points that we've been looking for. We've been looking at the x-intercept, and when we try to find an x-intercept, we let y equal 0. So in this problem here, if you let y equal 0, I'm going to do this as like the cover-up method and see if we can do this in our head. But if I cover this portion up, we think in our head, I can't show you with my finger covering up, but 100 multiplied by what would be 1,600. And what we know here is that this would be 16, 0. If I let x be 0, so we're not going to get any large, we're going to just go with a bunch of small rafts. Again, we can use a cover-up method. We can cover up this part and say that 0 times 100 would be 0. So 40 times what number would be 1,600? Well, that number, in fact, would be 40. And that's because 1,600 divided by 40 is, in fact, 40. Let's move into graphing, labeling. So here, let's label this axis here. This is the number of, if we're not sure, we look back how we define x at the top. This is the number of large rafts rented. This axis over here, the number of small rafts rented. And once again, they have helped us out and they started to give us a scale. They said horizontally, we are going to count by 5s. The one thing I don't like about them counting here by 5 is that if I do that, remember I only have to get to 16,0, and I need to get to 040. So we're going to flip this around, all right? We're going to change this. We're going to make this one counted by 5s, and we're going to change this down here to be counting by 2s. Again, that's based upon these values here that we're attempting to plot. So I get 5 and 10, and 15, and 20, and 25, and 30, and 35, and 40, 45, and 50. And horizontally, 2 4s, 6, 8, 10, 12, 14, 16, 18. I don't know why I got into design. I wanted to put all of those. But there I was able to get all the way out to 40. It might have been easier. I'm going to second guess that here. I'm going to go back and say, you know what? I think it would have been easier to count if we only have to get out to up to 40. We don't need to get up to 100. It might have been easier here just to count by 2s, right? Let's count by 2s and watch how much easier this is. 2 4 6. This is 8, 12, 16. 20, 24, 28, 32, 36, 40. I am going to rewrite my label in here since I lost it. Number of, this is small rafts rented. And now we can plot our points, which 040, I like the way 040 is popping up all the way up here at the top. 16,0 is actually right here. And we can draw our line in. I think I can do a better job than that. Oh, that one didn't like to go straight. It says fill in the chart and give us some possible combinations. Well, let's look at those grid lines and see if we can get some places where it looks or if it appears that they are intersecting at an integer. So you look and say, oh, I think I got one right here. At that point, there would be 4, comma 30. I keep looking. Here's another one, which is 8, comma 20. If you see a pattern, we are going down 1, 2, 3, 4, 5 over 2, 1, 2, 3, 4, 5 over 2, 1, 2, 3, 4, 5 over 2, and 1, 2, 3, 4, 5 over 2. This last one I was getting here was 12, comma 10. So it says fill in the chart, shows several combinations that work. I'm going to also list them here. These are the extra ones that are not in the chart. And these were all discovered from my grid lines where I found integers that worked. And remember, this was large rafts, comma, small rafts. So if we wanted to write a sentence, we would say, well, one combination that works is that you could have 4 large rafts and 30 small rafts. You could have 8 large rafts and 20 small rafts. But again, another situation here where we're looking at 2 rates, starting in standard form and working from there. So best of luck here as you move into day number 12 homework. And